Good morning. Good morning. Fine. So we were talking about basic concepts of chemistry. Okay. So can anyone can send the word what we have discussed in the last class? Just in a word. Which concept we have discussed in the last class? Yes, good morning, good morning. Okay, percentage composition. Okay, so that one we discussed yesterday. Okay, fine. I think we have discussed that one in day before yesterday. That is fine. So we have discussed about percentage composition. Right? So what is percentage composition? So it is related to 100, right? It is related to 100. Yes, we have discussed about calculation of empirical and molecular formula. Now before going for that, anyway, you people have told percentage composition, right? So now, what do you mean by percentage composition? That is nothing but what is that amount of a particular element present in a compound with respect to 100 gram of that particular compound. That's nothing but percentage composition. Fine. So for calculation of molecular formula or empirical formula, right? So that's what we have discussed. Molecular formula and empirical formula. Now, whenever we are talking about calculation of or finding empirical or molecular formula of a given compound, then during that time in the question they will be giving percentage composition. In the question they will be giving percentage composition. So in that case, to calculate the empirical formula, what is enough? We require only what is that percentage composition to calculate the empirical formula. Because once you know the percentage composition, you can find the ratio of those elements in that compound. Once you know the ratio of that element in that compound, then you have got the empirical formula. Fine. So to calculate the empirical formula, what is required? Percentage composition. Because if you know the percentage composition, then easily you can find out the ratio of those elements. Then you can easily discuss or you can easily write the empirical formula. Because empirical formula will give the information about the ratio of the element. Fine. So that's where we have the advantage of percentage composition. That is one thing. Now, to calculate the molecular formula, what is required? To calculate the molecular formula, we should know what is that empirical formula. To write the molecular formula, we should know what is that empirical formula. Okay, 1 minute. Now whether it is visible for all of you? Manjunath, now it is visible? Manjunath, whether you can see the board now? Ria, no means you cannot see the board? Whether all of you can see the board? Okay, some of you have written no. Okay, it's clear. Okay, some people it's clear. Okay, but whether now it is visible? Okay, I think it's visible now, right? Okay, cannot see. 1 minute. Now it's becoming blur and it's becoming clear, right? Okay, 1 minute. Good morning. Mayank is here only. Okay, for some students they have written clear. In that case, shall I start with the class? If it is clear. And now it has become like this. Now see, that change is happening. Okay, now it's bright. I will put off the light. Now, still it's bright.
Clear.
Okay, so fine. Okay, done. I will start. Okay, that's what we have discussed in the last class. Fine. So I will continue with the class and I will try to write it in large size. Okay, I will increase the font size. Now when I am talking about molecular formula and empirical formula, so that's what we have discussed in the last class. Very important one. Okay, so it's very important. Now we will come to the next part. That is with related to stoichiometric equations or stoichiometry. So we are going to talk about the stoichiometry. Fine. Now when I am talking about stoichiometry, so that is related to quantification or measurement, measuring the elements. That's where we have got the stoichiometry. Stoichios and another word is metry. Together stoichiometry, that is nothing but related to measuring or quantification of a matter or an element. Fine. Now when I am talking about chemistry, when you are writing a chemical equation, because all of us we know that when it comes to the chemistry, it is related to the reactions. So whenever we are writing the reaction, always we should know that it should be balanced, because already we have discussed about laws of chemical combination, where first law itself, it tells that there is no creation or there is no loss of any matter or element during the reaction, right? No matter will be created, no matter will be destroyed. So that's what the first law of chemical combination talks about. So in that case, when a reaction is happening, naturally no element can be lost. What I mean to tell here is, left hand side chlorine is there and right hand side in a equation there is no chlorine. It cannot happen. And once again, Dalton's law of atomic theory we have discussed. During the chemical reaction, there will be rearrangement of element will take place, right? But there is no loss. There will be rearrangement. whatever amount of elements are present on the reactant side of an equation, same amount of elements should be present on the right hand side, that is product side of the equation. Fine. So what I mean to tell you is, when I am talking about a chemical equation, when I am talking about a chemical equation, please remember that chemical equation is nothing but a representation of a reaction, because in a test tube or in a beaker some reaction will be happening, right? But that one we have to put it on the paper, we have to put it on the board. So that's where chemical equation is going to help. So chemical equation is nothing but representing the reaction which is happening in a test tube or in a beaker on the board, right? So that's where we have the chemical equation. So anyway, in detail as and all, whenever we are writing the chemical equation, I will explain. But for time being, please remember that whenever we are balancing the equation, first we have to balance less occurring element in that particular equation. Whichever element will occur less times, in reactant once and in product once, in reactant twice and in product once. So like that I am telling how many times that element will come into that equation. So whichever comes very less time, that one should be balanced first. And then if metals are involved in the equation, metals has to be balanced first. Then we should go for rest of the case. In most of the cases, when you balance the less occurring element in a equation, and when you balance the metal atoms in a equation, normally even other elements will get balanced. Fine. So that's what I mean to tell. That's how we have to balance the equation. Anyway, don't worry. Whenever it is required, I will explain whenever we are writing the equation. Fine. Now, for time being, I will write a simple equation. So that is combustion of methane. Combustion of methane. Now it is a sentence which tells that combustion of methane. Now we have to convert this sentence into a chemical equation, because combustion of methane is a sentence which is telling that there is one reaction which is taking place, right? So what do you mean by combustion? Combustion is nothing but burning of a hydrocarbon in the presence of oxygen. Burning of a hydrocarbon in the presence of oxygen, that is nothing but combustion. And whenever combustion is happening, there will be release of energy. Due to that energy, we are alive. Due to that energy, our vehicles will be running, because all of us, we know that in a vehicle we are putting hydrocarbons in the form of petroleum products. So these hydrocarbons, in the presence of oxygen, they will get oxidized, and that's where there will be release of energy. By using that, motor vehicles will be running. Same logic is applicable for diesel vehicles also. Even same logic is applicable for human being also, because even our body is like a machine. We require food for the energy. So whatever food we are consuming, it will get oxidized. So therefore, whenever we are respirating is happening, inhaling we will be taking oxygen, and outside exhaling we are going with carbon dioxide. So oxygen getting inside, carbon dioxide going outside. So what is that? Why we require oxygen? So that's where combustion is happening. But don't worry, in our body where there will be no catching of fire, nothing will happen, because it is a beautiful phenomena. Step by step it will happen, not at once. Okay? Anyway, in detail I will not go for that. Biology students, you will be knowing that one. Fine? So that's where we have the combustion. Right? What do you mean by combustion? burning of anything in the presence of oxygen. Okay, especially or normally it will be hydrocarbon. And methane is a small hydrocarbon, right? Now when I am talking about methane, that's where I have CH4. Now I told in the presence of oxygen, so therefore there will be presence of oxygen. Now it will be converted into, please remember, in the combustion process there will be oxidation, I told. So what do you mean by oxidation? Oxidation means removal of a hydrogen from an element. Oxidation means removal of hydrogen from a compound, or oxidation means addition of oxygen to a compound. Whether I am clear? So what can be called as oxidation? Oxidation is nothing but removal of hydrogen. That can be called as a oxidation. Okay? So that's where combustion is nothing but oxidation. In a redox reaction, you are going to discuss these things in detail, but for time being, I will brief it out. Okay? So oxidation means removal of hydrogen. Removal of hydrogen. Hydrogen atom. Okay? From a compound or from an element. So next, or addition of oxygen. Addition of oxygen. These can be considered as oxidation, either removal of hydrogen or addition of oxygen. Any one of these it is happening, then we can tell that a molecule or compound is getting oxidized. Now some of you have already given the product, very good. So that's where we have, whenever methane will get oxidized, product will be carbon dioxide and water. Carbon dioxide and water. So that's where, in this case, carbon is getting oxygen. Okay, carbon is getting oxygen in the product. Oxidation. Hydrogen which is attached to the carbon has been removed. Oxidation. So what I mean to tell here is, in a combustion process, there will be oxidation of hydrocarbons will take place. There will be oxidation of carbon will take place. So that's where we have the combustion of methane. All of you have understood? So in the product side we can see carbon is attached with the oxygen. It is getting released as carbon dioxide. And on the left hand side, carbon is getting attached with the hydrogen. So that means carbon is getting oxidized. So that's where we have the combustion. So methane, carbon is getting oxidized to carbon dioxide carbon. It is getting converted into carbon dioxide. So same logic, whenever we are eating a piece of bread, whenever we are eating a rice ball or ragi, whatever it is, so all these molecules will get converted into glucose, okay, or all this molecule can be oxidized to carbon dioxide by using oxygen. So therefore we are releasing the carbon dioxide during the respiration. Because whatever carbon dioxide will be formed inside our body, it has to be released. So that's where we have the combustion. Now if you observe the equation, whether equation is balanced? No, because here we have 4 hydrogen, there it is only 2 hydrogen. Now when it comes to oxygen, here it is 2 oxygen, there it is 3 oxygen, 2 and 1, 3 oxygen. Carbon is remaining same. So that shows that equation is not at all balanced. Got my point? So therefore first we have to balance the equation. Now target those elements which are less occurring in that particular equation. target those elements which are less occurring in the equation. See, for example, if I see the equation, this is the reactant side, that is product side, or we can call it as left hand side of the equation, and we can call it as right hand side of the equation, LHS, RHS, or we can call it as left hand side as reactant side, okay, and right hand side as product side, okay. So that's where we have the chemical equation. Now if you observe, on the left hand side carbon is coming once, that is in terms of methane. Carbon is coming as one time, and in the product also carbon is coming as one time in the form of carbon dioxide. So frequency of occurring of carbon in a chemical equation is 1. Left hand side once and product side once. Now when it comes to hydrogen, hydrogen is present on the left hand side in the form of methane. Hydrogen is present on the right hand side in the form of water. So hydrogen is also coming once. Frequency of occurrence is once, left hand side once and right hand side once. So carbon and hydrogen, they are matching. But when it comes to oxygen, left hand side it is coming as once, but right hand side it is coming as twice. So frequency of occurrence of oxygen is more, right? So left hand side it is once and right hand side it is two times, 2 places. Therefore, oxygen we should not be bothered. Oxygen, while balancing the equation, we should not be bothered. That is one thing. And if you observe, oxygen is present in its elemental form. Oxygen is present in its elemental form, that means pure form. So we should not be bothered at all. Please remember, whenever equation comes, you should not be bothered about that element which is in pure form. That can be balanced at the end. Okay? So therefore, in this case, first we should target either carbon or hydrogen because they are less occurring in the equation. So in that case, carbon, if I see, already it is balanced. Here also it is 1, here also it is 1. So already it is balanced. Next, we will go with the hydrogen. Yes, that's where we have 4 hydrogen, there it is only 2 hydrogen. So we have to make it 4 on the right hand side. So I will make it as 2H2O. I should make it as 2H2O. Many of you have written the equation, very good. Okay, so I will write it as 2H2O. Now, carbon, a less occurring element, is balanced. Hydrogen, a less occurring element, is balanced. Now we have to check whether oxygen is automatically balanced or we have to balance it. So if you observe it carefully, it's not balanced. Because here it is 2 oxygen atom, here it is total 4 oxygen atom. 2 is present here, 2 is present here. So total 4 on the right hand side. So what I will do is, without any delay, I will make it as 2O2. Because when I am writing 2O2, I am disturbing only oxygen. No other elements are there. It is a pure form. So therefore I told, a pure form of element, no need to worry. At the end we can balance it. So that's what I mean to tell. So that's where we have the balanced chemical equation or stoichiometric equation. Got my point? So this is nothing but combustion of methane. So this is nothing but combustion of methane. All of you have understood? So in a chemical equation, whatever is there on the left hand side, they are considered as reactants. Whatever is there on the right hand side, they are considered as product. Okay? Now I will alter the condition. I will alter the condition. Now that will become a reactant and this will become a product. Okay? So that will become a reactant, this will become a product if I alter the condition. If you go to the photosynthesis, biology students, So that's where plants will take up the carbon dioxide. Plants will take up the carbon dioxide and we are adding water to them. So that's where by using the energy sunlight, they will convert carbon dioxide and water into respective hydrocarbons like glucose. They can produce their own food, plants and all, right? So that's where it is a reverse condition. So what I mean to tell you is, I should specify, or depending on the condition, whatever I am providing for a chemical reaction, based on that it will be decided which will become as a reactant and which will behave as a product. But in this case, since I have written combustion of methane, it should be a reactant, that should be a product. Okay? All of you have understood? Now, this is, I have an equation. Now, in different way, I can explain a chemical equation. In different way, I can explain a chemical equation. See, for example, since it will be having bit high temperature, where methane, if I consider it one as a gaseous state, oxygen, naturally it is gaseous, carbon dioxide, gas, water also gaseous in state. Now, if reactants are gaseous in nature, I can express or I can explain that equation in terms of volume or partial pressure. Anyway, partial pressure is not required here. I can explain in terms of volume. That is molar volume. That is nothing but molar volume. If I observe how many moles of methane are involved in the reaction, if I see the equation, how many moles of methane are involved in the reaction? Can anyone? How many moles of methane are involved in the reaction? Yes, very good. So there is involvement of 1 mole of methane. Okay? How many moles of oxygen molecule is involved? Yes, all of you are right. Very good. 1 mole. That is with respect to methane. How many moles of oxygens are involved? Okay, Sahana, I think you have written for oxygen. Good. So how many moles of oxygen? It is 2 moles because 2 is there. So there will be involvement of 2 moles of oxygen. How many moles of carbon dioxide? Once again, all of you right, it is 2 moles. How many moles? It is 1 mole of carbon dioxide and it will be 2 moles of oxygen. Okay, so this is one way of expression. Okay, this is one way of expression. Now I can tell that during the combustion of methane, 1 mole of methane is going to react with 2 moles of oxygen. Listen to me carefully. In the exam, they may not ask directly, but there will be problems based on this, even in competitive exams. Okay, so 1 mole of methane is reacting with 2 moles of oxygen to form 1 mole of carbon dioxide and 2 moles of water. That's how I can explain the equation, this particular equation in terms of moles. Now, Rohan, very good, absolutely correct. So in that case, can we explain in terms of mass? Can we explain in terms of mass? So whatever I have explained, that is in terms of moles. Can we explain in terms of mass? Absolutely we can explain. Because since we have 1 mole, we can find the molar mass of methane. Since 1 methane is there, each methane, it will be 1 into 12 gram, that is related to carbon, plus 4 into 1 gram. That means 16 gram is the molar mass. And since 1 mole of methane is involved, in terms of mass it will be 16 gram. Yes, absolutely correct. Same way, when it comes to oxygen, So what is the molar atomic mass of oxygen atom? 16. Right? In one oxygen molecule it will be 32 gram. One oxygen molecule it will be 32 gram. But I have two molecules of oxygen. So two molecules of oxygen. So therefore it will be 64. It will be 64. 32 is meant for one molecule of oxygen. Fine. But since we have 2 moles of oxygen, it will be 64 gram. Got my point? Understand it properly? Because on this, we will be having question in terms of limiting reagent and all. And even in competitive exams, they will ask. Okay? So 16 gram of methane can react with 64 gram of oxygen during the combustion process. If I come to the right hand side, how many moles of carbon dioxide is there? It is only 1 mole. So that means we have to find the molar mass of carbon dioxide. That means 1 into 12 gram, that is related to carbon, plus 2 oxygen atoms, that means 32. 1 oxygen 16, 2 oxygen means 32. So therefore 32. So naturally it will be 44 grams. Some of you have written already. Right? Suchita, very good. Many of you have written. Very good, very good. Okay, that's where carbon dioxide will be 44 gram. Right? What about water? What about water? 2 moles of water. 1 water is 2 into 1 gram, that is related to hydrogen, plus 1 into 16 gram, that is related to oxygen. So therefore 18 gram is for 1 water. But how many water molecules are there? 2. You people have written already. Yes, 18 into 2. That means we have the 36 grams of water. Very good. Fine. So that's where we have the reaction. Another way of explaining the balanced equation. So now I can tell during the combustion of methane. Yes, all of you are right. Very good. Okay. So if you see the equation now, I can tell 16 grams of methane reacts with 64 grams of oxygen to form 44 gram of carbon dioxide and 36 gram of water. So this is related to a balanced chemical equation. So what I mean to tell here is, this is the optimum concentration and this is the optimum condition where this reaction can happen. Got my point? And that's where we have the balanced chemical equation, which we have expressed in terms of mole, which we have expressed in terms of mass. Now can we explain in terms of volume? Can we explain in terms of volume? I can give a hint. We have to apply Avogadro's law and we have to apply molar volume. Already I have explained what I mean by molar volume. So molar volume is nothing but volume occupied by 1 mole of a substance. Volume occupied by 1 mole of a substance. So can you tell me, considering 25 degrees Celsius, we will consider 25 degrees Celsius. I am specifying the temperature also. Okay. Rohan, 22.4 liter. Yes, very good. But that is at 0 degrees Celsius. Now I am specifying it as 25 degrees Celsius. So that means you people are right, but that is at 0 degrees Celsius. Now I am talking about room temperature. If that is the case, it will be 24.7 liters. Since 1 mole is there. What about oxygen? What will be the volume of oxygen? Methane is 24.7 liters. What about oxygen? Yes. So make it 24.7, Rohan, not 22.7. At 25 at or room temperature, it will be bit higher volume, that is 24.7. Okay, since 2 moles of oxygens are there, it should become 24.7 into 2, right? So what will be the answer? Okay, 45.4 liters. Okay, fine, absolutely correct. 45.4 liters. So that's where we have the volume. What about carbon dioxide? 1 mole. So therefore 24.7 liters. Water 2 moles. Therefore 45.4 liters. Right? So that's where in terms of volume we can express. So based on the balanced equation, we can tell that during the combustion of methane, 24.7 liter of methane is going to react with 45.4 liter of oxygen. Okay, Stephen, why 49.4? Okay, I have to cross check. Oh yes, 49 it will be. I think Rohan, you are taking 22.7. Okay, so last 4 came, so I thought it's correct only. So it will be 49.4. Whatever Rohan has written, it will be for 22.4. 7. Okay, so 49.4. Okay, that's where we have the equation. Yes, now it's correct. Yes, all of you are right. I did a mistake. So I told 24.7, but while writing, I wrote it for 22.7. Okay? Okay, fine. Yes, Rohan, but I didn't see Appa. Okay? So that's where we have the 24.7 liter, 49.4 liter, 24.7 liter and 49.4 liter. That's where you can see Avogadro's law is applicable here. Right? On the right hand side, it is water gas, water present in gaseous state. 2 moles, 49.4 liter. Left hand side, oxygen gas, 2 moles, same volume, 49.4 liter. Carbon dioxide, 1 mole, 24.7 liter. Methane, another different gas, still it will be occupying 24.7 liter only. So that's where we have the molar volume concept, and that's where we are following the Avogadro's law also. Okay? So this is how a stoichiometric equation can be explained in a different manner. Okay? So that's where we should know which and all form we can explain the stoichiometric equation. But observe it carefully, but whenever we are explaining like this, we should make sure that equation is balanced. A balanced chemical equation is very much required. Without balanced chemical equation, we are going to have the wrong answer. Okay? So whatever problem we will be solving next, all of them, they require first writing the balanced equation. So without balanced chemical equation, no, it's not possible to calculate. Say for example, I will give one problem. Okay. All of you can write it down. Calculate the moles of methane. Calculate the moles of methane required to produce 11 gram of carbon dioxide after combustion. What is that problem or question? Calculate the moles of methane required to produce 11 gram of carbon dioxide after combustion. Can you tell me the answer? This is how question will be there. Okay, this is how question will be there. It is based on stoichiometric equation just now, based on balanced chemical equation. Okay, so now to answer this question, first you should write a balanced equation. 1 mark will be given to this. Okay, 1 mark will be given to this. But with respect to board exam, very often they have not asked about this concept. But here and there, sometimes they have asked. But for competitive exam, it will be helpful for you. And it will be bit twisted also. So methane with oxygen getting converted into carbon dioxide and water. Right? Now we have to balance it. So 2O2 and 2H2O. Okay, that's where I have the balanced equation. First thing. Now according to this balanced equation, now I can tell that 16 grams. I will not go with moles. I will directly go with the mass. Chidwan, I will not worry about the moles. And then, yes, we have to require moles. Beginning, I will write it in grams because they have told 11 grams. So, therefore, 16 gram is going to react with the 64 gram of oxygen to produce 44 gram of carbon dioxide and 36 grams of water. Okay, so this is a balanced equation. Based on that, just before also we have written, once again I have written the same thing. Got my point? Now, whatever given data is there or given information, what is that given information? They have told 11 gram of carbon dioxide will be produced. 11 gram of carbon dioxide will be produced. So already we have written balanced equation, don't worry. So we have 11 gram of carbon dioxide in the question. So now what we can do? Any one of the reactant we can pick. Any one of the reactants we can pick and we can calculate the carbon dioxide produced. For 11 gram, how much reactants will be required? That one we can calculate easily. Got my point? Since they have asked about methane, we will focus on methane. See, for example, based on the balanced equation, this is the given information. Based on the balanced equation, we can tell that for 44 gram of carbon dioxide, how much methane is getting utilized? Methane is getting utilized is 16 gram. 16 gram of methane. So how much they have told? 11 gram. So therefore, for 11 gram of carbon dioxide, how much methane will be required? So grams of carbon dioxide will get cancelled. The answer will be grams of methane. Grams of methane. So that will be, some of you have already written. So that will be 4 grams. So that will be 4 grams of methane. Very good. But next is there. It's not the final answer. Many of you will stop here. This is not the final answer. If you observe, they have asked about moles of methane, not the mass of methane. Okay? So whatever 4 gram of methane we have got, it is in terms of mass. We have to convert that one into moles. So how to convert? By using molar mass concept. By using molar mass concept. Okay? So Andani, that's what? That is not the final answer. We have to convert that one into number of moles. So therefore, how to calculate the mole? Mole is equal to given mass divided by molar mass. Yesterday I have told. This equation will be very useful. So therefore, yes Rohan, 16 gram corresponds to 1 mole of methane. Yes. So we have to use the equation, which is that mole is equal to given mass divided by molar mass. Given mass here is 4 gram. Molar mass is 16 grams. So therefore, moles of methane is equal to 4 gram divided by 16 gram. From where this 4 gram came? 4 gram we calculated. 4 gram we have calculated. So therefore 4 gram divided by 16 gram. Given mass divided by molar mass. That will give the number of mole for any of the element. So what will be the answer? I think some of you might have written beginning itself. So the answer will be 0.25 moles. That will be your final answer. That will be your final answer. 0.25 moles. Okay? So Andani, why? Okay, fine. 0.25. Yes. So 0.25 moles. Okay, that's where we have the moles of methane. Since they have asked in terms of moles of methane. Sir, why mole is equal to given mass divided by molar mass, sir? From where that equation came? It's very simple. For a molar mass, 1 molar mass of any compound indicates 1 mole of that particular compound. All of you will agree? Fine? Okay, you can write it in fraction, but why you want to go with fraction? It's very simple. You can write it in 0.25 moles, no problem. Okay? But only thing is final unit you have to write. You have to write mole as the unit. Okay? So now, why that moles is equal to given mass divided by molar mass? That is because for 1 molar mass of any compound, it corresponds to 1 mole of that particular compound. How much for given mass of same compound? If you observe it carefully, 1 multiplied to anything will remain same. So therefore, given mass divided by molar mass will give number of moles of any compound. Got my point? So given mass divided by molar mass of any compound will give number of moles of that particular compound. All of you have understood? Any doubt in this problem? Shall we move to the next one? So that's where we have one of the problem. Okay? So like this you can expect in your exams also. If it is asked, it will be for 2 marks. For balanced equation, 1 mark will be there. Then for solving the problem. If you don't write the unit, then you are going to lose the marks. And now, we don't have half marks concept. So if they are deducting, it will be complete 1 marks will be deducted. So try to keep the unit proper for your final answer. Okay? Next one. We will solve another one. Any doubt in this? Okay. So write it down, all of you. Calculate the amount of oxygen used for the combustion of 60 grams of glucose. 60 grams of glucose. Can anyone give me the answer? What is that question? Calculate the amount of oxygen used for the combustion of 60 grams of glucose. So instead of methane, I have written it as glucose. Can any one of you tell me? What will be the answer? Okay? So first, what we have to do? First, we have to find the, or we have to write the balanced equation. To write the balanced equation, we should know formula for glucose. That is C6H12O6. This is what will happen. All of you, when we eat a piece of bread, this is what will happen in your system, in your body. But only thing is, this reaction will happen in a step-by-step process. Okay? So glucose with oxygen getting converted into carbon dioxide and water. Carbon dioxide and water. So whether it is a balanced equation? No, it's not a balanced equation. So first we will target less occurring element. Which is that less occurring element? Carbon and hydrogen. Because on the left hand side once they are coming, and in right hand side also only once they are coming. So therefore carbon and hydrogen are less occurring element. So carbon, how many are there? 6. So we have to make it as 6. Hydrogen, how many are there? Hydrogens, on the left hand side it is 12. So we have to make it as 6. Now less occurring element has been balanced. Both carbon and hydrogen, they are balanced. Now what about oxygen? They are not balanced. So since pure oxygen is there, we have not given any importance to the oxygen. At the end we have to balance. So now we are going to balance the oxygen. On the left hand side, total 8 oxygen atoms are there. It's not 80, it is 8 oxygen atoms are there. On the right hand side, it will be 12. 6 2s are 12 oxygen and 6 oxygen. Total how many are there? 8 oxygen atoms are there. So 12 it is 8. On the right hand side it is 80. So now what to do? So we have to add a required number to this oxygen, not here. We have to write the required number to here. We have to make on left hand side also 80. So we have 8. Yes. Rohan, not 302. Yagnesh, what you have written is correct. It should be written as 6. That is because 6 2s are 12. 12 plus 6, it will be 80. So that's where we have a balanced equation for combustion of glucose. Ganavi, it cannot be 3. So if you make it as 3, it will become 3 2 is 6 plus 6, it will become 12. But we want 18. So we have to make it as 6. Yes, now correct. We have to make it as 6. So 6 oxygen. So this is where we have the balanced equation. All of you have understood? Now can you write it down? Answer for this one. Okay. So molar mass of glucose will be 180 gram. Because we have already discussed in the previous classes. 180 gram. So since 1 mole of glucose is involved, we have to have 180 gram. So what about oxygen? 6 oxygen molecules are there. So therefore, in terms of grams, it will be 192 gram. Okay, in terms of grams, it will be 192 gram. Since they have asked about amount of oxygen used for 60 gram, right hand side I am not bothered. Right hand side I am not bothered because they are asking about oxygen and glucose which are present on the left hand side. Now what I have to do? We have to find out what is that amount of oxygen required. So based on the equation, based on the balanced equation, not on the equation, based on the balanced equation, now we can tell that for 180 gram, for 180 grams of glucose, how much oxygen will be required? 192 gram, or 192 grams of oxygen will be utilized. How much for 60 grams of glucose? How much oxygen will be utilized? So that's where you have to get the answer. Based on the balanced equation, we know that for 180 gram of glucose, 192 gram of oxygen will be utilized. What is that for 60 gram of glucose? How much oxygen will be utilized? So therefore, grams of glucose will get cancelled. So final answer will be in terms of grams of oxygen. So what is that answer? Okay, that will be 64 gram, right? Yes. So that will be 64 gram. You can stop here. 64 gram. Or you can write it in terms of moles also. You can, since they have asked about amount of oxygen, if you stop here, then also you are going to get the marks, no doubt. If they would have asked about moles of oxygen, then you have to convert that one into moles. So how to convert? That is based on the molar mass concept. For 32 grams of oxygen, it corresponds to 1 mole. How much will be there in the 64 grams of oxygen? How much will be there in the 64 grams of oxygen? Or straight away, given mass divided by molar mass. Given mass divided by molar mass. Why 4, Anju? Why you have written it as 4? 64 divided by 32. Yes, it should be 2 moles. So it will be 2 moles of oxygen. 2 moles of oxygen will be used. Or in terms of mass, it will be 64 grams of oxygen. All of you have understood? But in this problem, if you stop at 64 gram, then also you are going to get the complete marks. Don't worry. Then also you are going to get the complete marks. Okay? Any doubt in these problems? Okay. In that case, I will stop here. If you don't have any doubt, I will stop here. Now, in the tomorrow's class, we are going to discuss about limiting reagent. Very important concept for your concept, that is limiting reagent. So based on that, you can expect the problems or you can expect the definition. Define or what are limiting reagents, like that 1 mark question can be there, or you can expect the problem. So tomorrow's one is bit important one. Okay? So any doubt? Okay, fine. No doubts. Okay. So what you can do is at home, since we have done with the up to this, we have done stoichiometric equation, you can solve some more problems from your textbook and even from your check sheet, whatever has been provided. Any doubt, let me know. Okay? Okay, thank you. Take care. So tomorrow, once again, I will be back. Okay, na? Devil will be back. Okay, thank you.